Magandang buhay mga bata! Tara, samahan ninyo akong matuto kasama si
Teacher Aika, your online teacher. Please don't forget to subscribe, like, share, and hit the notification bell for more videos. Thank you! Matatag Curriculum, Science, Grade 5, Quarter 1, Lesson 2. Our topic for today is about matter, states, and characteristics. This is Teacher Aika, your online teacher. Let's start! Learning competencies and objectives. The learners describe the properties of solids, liquids, and gases in terms of shape and volume. A. Solids, definite shape and volume. B. Liquids, no definite shape, definite volume. C. Gases, no definite shape or volume. The learners will be able to differentiate solid, liquid, and gas based on their molecular attraction, arrangement, shape, and volume. Let's have a short review. Today, we shall have a game as a form of review of your lessons last week. We will call this game Phase Race, solid, liquid, or gas. Group game Phase Race, solid, liquid, or gas. Materials, 3 boxes of containers labeled solid, liquid, and gas. Various pictures of real small objects representing each phase of matter. Example, ice cube for solid, water for liquid, balloon for gas, and timer or stopwatch. Instructions: divide the students into small groups or teams. Explain to the students that their task is to sort the objects into the correct boxes based on their phase of matter. When you say go, one student from each team will race to pick up an object, identify its phase of matter, solid, liquid, or gas, and place it in the correct box. Once they've sorted an object, they should return to their team and tag the next player to go. The game continues until all objects have been sorted or a set time limit. Example, 3 minutes has been reached. Here are some questions that you need to answer. What makes an object a solid? How can you tell if something is a gas? Can you give examples of each phase of matter from everyday life? Last week, we explored the unique characteristics of matter and delved into its various phases. This week, we'll dive deeper into the fascinating world of matter that surrounds us every day. Through engaging activities, we'll further our understanding of the properties that define solids, liquids, and gases, empowering us to better appreciate and comprehend the world of materials around us. For you to understand our topics better, try to familiarize yourselves with these terms by arranging the jumbled letters to come up with the correct term being described. Our first jumbled word is umelov. This is the amount of shape occupied by an object or substance. The answer is volume. Volume. Second jumbled word. It is a graphical representation of an object's form or its external boundary. outline, or external surface. It is distinct from other object properties such as color, texture, or material type. The answer is face. Face. Day 1, subtopic number 1, properties of solid, liquid, and gas. Let's have an activity. What are shown in the picture? Let's identify. A. Stones. B. Water. And C. Balloon filled with air. You have learned last time that all matter can exist in 3 states, namely solid, liquid, and gas. Do you know that these 3 states of matter have different properties? Do you want to know more about the properties of solids, liquids, and gases? Let us see what you think you know about the properties of matter and what you want to know about the properties of matter by filling up the table below. What you think you know, that's T. What you want to know, that's W. What you learned, L. And how you know, H. Day 2, subtopic number 1, properties of solid, liquid, and gas. Worked example, let's investigate. Team time, let's work together. We'll make 5 fun teams today. Each of you will get a special job and wear a color visor to match. Manager, red. The team boss keeps everyone working together. Speaker, blue, talks for the team when it's sharing time. The director, green, helps the team follow the steps and stay on track. Reports coordinator, yellow, writes down ideas and keeps notes neat. Put on your visor, do your job, and let's be a super team. Activity number 1, observing the shape of the 3 states of matter. Objectives. Describe the properties of solids, liquids, and gases in terms of shape. And B. Differentiate the distinct shapes exhibited by the 3 states of matter, solid, liquid, and gas, through hands-on exploration and observation. Needed materials: a stone, water, 3 balloons. Instructions: gather and work in group. Together with your teammates, perform the activity. Here's the procedure. 1. Put the stone into the balloon and tie the top of the balloon, while the second balloon with water. Blow up the third balloon. Tie the mouth of the balloon. 2. Press the stone, water, and air in the balloon and observe the changes in their shape. 3. Based on your observations, answer the given questions. And 4. Share your findings with your classmates. Discuss how the shape of the 3 states of matter is similar or different. Here are the questions for our activity. A. What happened to the shape of the stone when you pressed it? B. What happened to the shape of the liquid when you pressed it? C. What happened to the shape of the gas in the balloon when you pressed it? D. What shape do solid, liquid, and gas have? And E. How similar or different is the shape of the three states of matter? Let's have the discussion. Based on the activity we have conducted and observing the shape of the three states of matter. 1. What property of matter was shown in the activity? Answer. Shape is one of the properties of matter. 2. What happened to the shape of the stone when you pressed it? Answer. Nothing happened. It remained the same. 3. What shape do solids have? Answer. A solid has a definite shape. The shape of the solid remains the same whether it is pressed or placed into different containers. For example, a stone will keep its shape whenever we press it or put it on a desk, or in a glass, or in a box. This means that the shape of a solid does not change. Solids have definite shapes. 4. What happened to the shape of the liquid when you pressed it? Answer. The liquid changes its shape when it is pressed. Liquid also changes its shape to match the shape of the containers. Liquid has an indefinite shape. The liquid changes its shape when it is pressed. Liquid also changes its shape to match the shape of the containers. For example, liquid takes the shape of the glass when it is poured into a glass. Liquid also changes its shape when it is spilled on a table. A liquid has no definite shape. 5. What happened to the gas in the balloon when you pressed it? Answer. The shape changed. The occupied volume changed as well. 6. What shape does gas have? Answer. Gas has an indefinite shape. Gas changes its shape as it takes the shape of the container. If we fill differently shaped balloons with air, the air expands to fill the balloons and takes on different shapes. If the balloon bursts, air will escape and spread out. Day 3 to 4. Worked example. Activity number 2, exploring volume as a property of solids, liquids, and gases. Objectives, describe the properties of solids, liquids, and gases in terms of volume, and differentiate the distinct volume exhibited by the three states of matter, solid, liquid, and gas, through hands-on exploration and observation. Materials needed: 3 clear containers, preferably of the same size and shape. Water, a few solid objects such as marbles, coins, or beads. A balloon, measuring cup, and marker or pen. Instructions: gather and work in a group. Together with your teammates, perform the activity. Procedure: 3. Inflate the balloon to a moderate size. 4. Observe and present your findings to the class. 5. Based on your observations, answer the following questions. A. Observing the volume of solids. A. Describe the solid objects you observed in the container. B. How did the solid objects fit into the container? Were there any gaps or spaces between them? C. Did the volume of the solid objects change when they were placed in the container compared to when they were outside the container? D. Based on this activity, can we conclude that solid has a definite volume? B. Observing the volume of liquids. A. Describe the container filled with water. Did the water completely fill the container? B. How did the water take the shape of the container? Did it fill all the corners and edges? C. How did you measure the volume of the water in the container? What unit of measurement did you use? D. Did the volume of the water change when you poured it into the container compared to when it was in the measuring cup? And E. Based on this activity, can we conclude that liquid has a definite volume? C. Observing the volume of gases. A. Describe the inflated balloon. How did it appear in terms of volume? B. Did the balloon completely fill with air? C. Did the volume of the balloon change when you inflated it compared to when it was deflated? D. Based on this activity, what can we conclude about the volume of gas? Let's have discussion. Observing the volume of solids. 1. Describe the solid objects you observed in the container. Answer: the solid objects were small marbles made of glass. 2. How did the solid objects fit into the container? Were there any gaps or spaces between them? Answer: the solid objects filled the container, but there were small gaps between some of the marbles. 3. Did the volume of the solid objects change when they were placed in the container compared to where they were outside the container? Answer: the volume of the solid objects did not change when they were placed in the container. 4. Based on this activity, can we conclude that solid has a definite volume? Answer: yes, solid has a definite volume. The volume of a solid can be calculated using various methods depending on its shape. You will learn this in our succeeding lessons. Observing the volume of liquid. 1. Describe the container filled with water. Did the water completely fill the container? Answer: the container was filled with water, and the water filled the container. 2. How did the water take the shape of the container? Did it fill all the containers and edges? Answer: the water took the shape of the container and filled all the corners and edges. 3. How did you measure the volume of the water in the container? What unit of measurement did you use? Answer: we measured the volume of the water using a measuring cup and poured it into the container. We use milliliters or ml as the unit of measurement. 4. Did the volume of the water change when you poured it into the container compared to when it was in the measuring cup? Answer: the volume of the water did not change when we poured it into the container. We used the same measuring cup for both measurements. 5. Based on this activity, can we conclude that liquid has a definite volume? Answer: yes, liquids have a definite volume, meaning they occupy a fixed amount of space regardless of the container's size or shape? Observing the volume of gas. 1. Describe the inflated balloon. How did it appear in terms of volume? Answer: the inflated balloon appeared to be full of air and was moderately sized. 2. Did the balloon completely fill with air? Answer: the inflated balloon appeared to be full of air and was moderately sized. 3. Did the volume of the balloon change when you inflated it compared to when it was deflated? Answer: the volume of the balloon increased when we inflated it compared to when it was deflated. 4. Based on this activity, what can we conclude about the volume of gas? Answer: gas has no definite volume. The gas filled the balloon, causing it to expand. The volume of the gas increased to fill the available space inside the balloon, demonstrating that gases do not have a fixed or definite volume. Gases expand to fill the container they are in, and they have indefinite volume compared to solids and liquids, which have fixed volumes. 5. Can you think of other examples where gases expand or compress to fill their containers in everyday life? Answer: the gas inside the LPG tank is compressed to fit the tank. Once you open it, the gas inside is released to light up the stove so you can use it for cooking. Learners' takeaways. Therefore, who can describe the properties of solids, liquids, and gases in terms of shape and volume? Solids have their own shape and take up a set amount of space, definite volume. Example: a book stays the same shape and size. Liquids do not have their own shape but still take up a set amount of space. Example: water takes the shape of the cup, but the amount stays the same. Gases. Gases have no shape and no set amount of space. They spread out everywhere. Example: air fills up a balloon or a whole room. Reflection on learning. Go back to the TWLH chart. Let the students reflect and check if their answers in the think column are correct. Ask them also if their answers in the one column were addressed during the conduct of the various activities. Finally, let them accomplish the learned and how column. Formative Assessment, Part 1, Multiple Choice Questions. 1. Which property best describes a solid? A. Indefinite shape. B. Indefinite volume. C. Definite shape and volume. D. No shape or volume. 2. What happens to the shape of a liquid when poured into different containers? A. It retains its original shape. B. It changes to match the shape of the container. C. It expands to fill the container. Or D. It evaporates immediately. 3. How does the volume of a liquid compare when poured from one container to another? A. It increases. B. It decreases. C. It remains the same. Or D. It becomes indefinite. 4. What shape does gas take when filled in differently shaped balloons? A. It retains its original shape. B. It takes the shape of the balloon. C. It expands outward. Or D. It becomes a liquid. 5. Which phase of matter has a definite shape and does not take the shape of its container? A. Solid, B. Liquid, C. Gas, or D. Plasma? 6. What did you observe about the volume of the solid marbles placed in a container? A. The volume increased. B. The volume decreased. C. The volume remained the same. D. The volume became indefinite. 7. How did you measure the volume of the water in your activity? A. You weighed the water. B. You counted the droplets. C. You used a measuring cup and milliliters or ml. And D. You guessed the volume. 8. What can you conclude about the volume of gas based on the balloon activity? A. Gas has a definite volume. B. Gas has an indefinite volume. C. Gas has a definite volume. D. Gas occupies the least space. 9. Which phase of matter can be expanded or compressed to fill its container? A. Solid, B. Liquid, C. Gas, or D. Plasma? 10. What happens to the volume of a gas when it is compressed? A. It increases, B. It decreases, C. It remains the same, D. It becomes a solid. Part 2, situation-based questions. 1. Situation. Sarah has a glass of juice that she forgot to drink and left it on the table overnight. When she checked it the next morning, the level of juice in the glass had decreased. What happened to the volume of the juice? A. It increased, B. It decreased, C. It remained the same, or D. It evaporated completely. Situation number 2. James has a balloon filled with air. He decided to squeeze the balloon gently. What change did James observe in the balloon? A. The balloon's shape remained the same. B. The balloon's volume increased. C. The balloon's volume decreased. Or D. The balloon's volume remained the same. And here's the formative assessment answers. Part 1. 1. C. 2. B. 3. C. 4. B. 5. A. 6. C. 7. C. 8. B. 9. C. And 10. B. Part 2. 1. B. 2. C.
Maraming salamat sa panonood. Huwag kalimutang i-like at mag-subscribe para sa higit pang educational content. I-click ang bell icon para ma-update ka sa ating mga bagong video. Salamat!